Hey everyone, thanks for joining today's event, How to Grade Your Selenium Tests. My name is Adi and I'm the event's moderator. Today's speaker is Dave Haeffner. As all of you know, Dave is a test automation and Selenium expert. He's the writer of Elemental Selenium, a free once-weekly Selenium tip newsletter, author of the Selenium guidebook, and the creator and maintainer of Chemistry Kit. He's also a founder and co-organizer of the Selenium Hangout and has spoken at numerous conferences and meetups about automated testing. Just before Dave kicks off, a few important things to keep in mind. Feel free to ask questions during the webinar. You can do that in the GoToWebinar control panel on your right. We will try to answer as many questions as possible at the Q&A session at the end. The webinar is recorded and the link to the recording will be emailed to you tomorrow. For optimal viewing experience, I strongly recommend you close off any unnecessary apps running in the background. And if you encounter any technical issues, please send me a private message in the chat room. I am the Applitools event organizer, and I will try to take care of it as soon as possible. So, Dave, the stage is yours.
Hey, hi. Can you hear me okay? And my screen, is it showing?
Yeah, it is.
Great, okay. Hi everybody, thanks for joining, and I'm really excited to talk about this topic because it is something that I've been thinking about for several years at this point.
Dave, I'm sorry to cut you, but no, we can't see your screen we can't see your presentation for some reason.
Okay, how about now?
Now we see your files. We don't see, yeah, now we can see it.
Okay, weird. Cool. Great, let's try that. Okay, so I'm excited to share this topic with everybody just because it's forced me to kind of quantify everything that I've been thinking about because I've been recently starting to put it into practice. The idea of how do you take something that seems fairly subjective, you know it when you see it, and putting it into practice in a repeatable way that can be applied to anyone's test code. Your test code, if you switch between teams in your company's test code, you switch between companies' test code with Selenium. And so let's talk about tests. And so I'd like to start by just saying, let's ask a question. If we were to ask each person here in a group setting what makes a bad test, I think we would get kind of a smattering of answers, and they might kind of range something like this. We might see people who say, tests that fail for no good reason. That's a bad test. It may be just because it's a false positive, a transient failure, those kinds of things. Changes in the application that we're testing, application under test. If there is a change and it forces us then to go and update multiple tests, then potentially those tests are pretty brittle. It might not withstand the test of time. Of course, it depends on what kind of changes happen in the application that you're testing, but if it's something that's not actually a fundamental rewrite of a feature and potentially just like the page gets reoriented in terms of where elements are located, then potentially that's something that would draw cause for thinking a test is bad. Tests that are slow, and inherently Selenium has this bad rap and has over the years of tests being slow, brittle, and hard to maintain. And slow tests can invariably lead you to think that a test is bad. Of course, the caveat to a slow test is it really depends on what you're comparing it to. So if it's slow in regards to you have other Selenium tests and they perform pretty quickly, and this other test just seems to really be slow, then that's definitely a cause for consideration that it might be a bad test. Tests that are unreliable, that don't actually work consistently and create a lot of noise, those are perfect candidates for bad tests because they can erode the trust that you and your team have in the test suite that you're working on. And then tests that are, of course, hard to understand and they're hard to maintain. And again, these are largely subjective, know it when you see it things. And so, but if we were to have this kind of thought process, this conversation, I think this is a rough set of answers that people might come up with. Now, if we take the flip side of this coin and say, well, what makes a good test? Well, let's talk about that. I think a good test, ideally, should be written for some kind of existing test framework, like a behavior-driven development or a unit testing framework. And each test that you write should test one thing. Tests should be atomic. And of course, you want to make it so each test ideally can be run independently. So there's no dependencies between tests. So each test should be autonomous. And then you want to make sure that anyone, including yourself, 6 months from now, can understand what a test is doing. And this goes back to just understandability, which leads to things like helpful names and those kinds of things, and also just not being clever. And this is kind of an aside, but anytime that you think a solution in your test code, either one you've written or one that you've found that someone else has written, if you think it's clever, if you think it's doing something fancy, then that's a cause to think, maybe this isn't a good test, because clever typically leads to brittle, which typically leads to hard to understand and hard to maintain. And so that's also just a hint that maybe there's some opportunity there to clean up your tests. And ideally, you want tests to be grouped similarly. So if you have a bunch of tests that exercise login, then potentially those would all want to live within one place within your test code, and as opposed to kind of scattering them to the winds. And I always put this here just as a reminder to people that through a good test framework, you actually can execute disparate tests into dynamic groupings using metadata typically. Within Java and JUnit, then you have something called categories. Within the Ruby world, you have tags, and within C# you have attributes, and in Python you have decorators, and so the list goes on and on. And then ideally, your test should leverage some kind of centralized setup and teardown. So you don't want to repeat the incantation to create a custom browser every time. Ideally, this would be something that's centralized so that you can customize it, configure it, enhance it, so that you can add in additional benefits like screenshots on failure and running it on a remote grid, incorporating automated visual testing through a third party like Applitools, and so on. And so there's really a lot of benefits to this kind of architectural consideration. And then the last one, which is just kind of the most concise one here, is they use page objects. And I'll cover page objects in the next section, but that's basically, fundamentally, this is what makes a good test. This is a reasonably good and sound way to have a well-structured test. And so, again, most of these are actually somewhat subjective. Like, they're not necessarily something that's easy to quantify. And so, to make this more concrete, here is a rubric with some more rigor around exactly what you should look for in your tests. And I've started basically putting what I'm about to show you between tests, page objects, and locators into practice within existing test suites. And it's really been an impressive, helpful indicator of which tests need work and what things within them actually need to be improved. And so the way to think about it is a lot like when you were in school. You're in a class and you're given an assignment, a homework assignment or a test. And when you receive that test back, there is a grade attached to it. There are a number of questions, you have to fill them out, and then there's a grade. It's either A through F or it's out of 100%. And so each rubric I'm going to show you follows a very similar construct. By the end of it, each item that you're testing, or each item that you're grading rather, so in this case, if you take a single test and grade it using this rubric, you should end up with a grade. And then you can convert this numerical grade into a letter grade if you so choose. So basically, every test that you want to review starts with 100 points, and then you would deduct points as necessary based on the criteria in this rubric. And so the first one follows this pattern of there's a thing that we're going to look for, and whether or not it belongs in a test, and then there is a deduction or not, depending on the answer to whether or not it belongs in the test. And so the first one is Selenium commands. Given that the goal of writing our tests in a good structure revolves around the idea of using page objects, then all of our Selenium commands should be taken out of our tests and put into page objects. And so they should not belong in our tests. And so if you have Selenium commands in your tests, then you really want to deduct points. Now, we don't want to, of course, just lead to an automatic an imminent failure because you happen to not be using page objects in certain places, but this is a helpful way to reduce the score enough to give you an indication that there needs to be some improvement made. So for each Selenium command up to 3, you would deduct 3 points each. So if you have 3 commands in a test, then you would say, oh, I need to deduct 9 points. And then locators follow the same construct, and of course, 99% of your Selenium commands use locators, and so they should not belong in tests either. Same pattern applies. For each one you see, or a similar pattern rather, for each one that you see, you would deduct 2 points up to a maximum of 8 points. And then Selenium setup and teardown. So the central setup and teardown that I mentioned on the previous slide, this should not be in your test. And if it is, then we'll want to deduct 20 points. And this is a heavy deduction because this is something that should really be considered to be taken quite seriously, since it really does, it is an architectural consideration that makes a huge advantage in terms of maintenance of your test suite over time. The caveat here, there's an exception to this. There are times where you might not necessarily, due to some kind of constraint within your application, you might not want to have your tests, each test open its own browser. You might need to, in an actual test class, reuse a browser instance between tests due to some, like I said, some sort of constraint where it's a really expensive operation. And there's something probably tied to test data typically in those circumstances where it's just a really expensive operation to launch a browser, do all this preamble to get a user and get the system into a certain state. And so when that happens, then potentially this exception can be this rule could be overlooked because of that. But for the most part, under most circumstances, no, you should just have a central setup and teardown. And then in terms of how you're weighting, any sort of synchronization that's going on in your testing shouldn't happen in your tests. So hard-coded sleeves, in general, you should never use hard-coded sleeves, but they should also not belong in your tests if you happen to be using them. And if there are any in your tests, then it's -5 for each one, up to 4 of them, which would be a max of 20. And then implicit wait calls, because Selenium has 2 different wait functions, an implicit wait and explicit waits. Again, any wait functions shouldn't be in your tests, they should be in your page objects. Although with the implicit wait function, that's typically in the central setup and teardown, so depending on how you use it. And so if that happens to end up in your test, then it's -10. And explicit waits also no. And these two, the -10 and the -3 for implicit and explicit, those it's just if you see it, just deduct that amount. If there's more than one, don't worry about it. That's just a flat deduction. And then conditionals. There should be no conditionals in your test. So you should go ahead and deduct points for each one you see. And this gets back to cleverness. Like if there's or as I'll say, a hint. Like if you end up seeing conditionals where a test should only run under certain conditions, or if the page is this, then it should do this versus that. Like that kind of stuff is a hint that that should belong somewhere else, potentially an abstraction in your page objects, or potentially you need to rethink how you're actually writing your test. And so these things should be abstracted or rethought and put into the correct places. And if they're not, then you end up with these deductions. And if you make these changes and follow this kind of rubric here, then you should end up with tests that are better structured, easier to understand, easier to maintain, and correct abstractions have happened in the correct places. Some other things, calls to page objects, those should belong in your tests, and so there's no score deduction for that. And then assertions. I mean, this is really the bread and butter of why we do a test. Every test should have an assertion. And then with that, there's of course no deductions. A point about assertions, it's kind of the whole why we do this. Like we use Selenium to drive the browser to mimic human action, and then we get some information about the page, and then we use our test framework to perform an assertion, some sort of check some sort of assumption about the page, the state of the page. And so ideally your test ends with an assertion. And ideally you're testing a concept. This goes back to a test being atomic. It's testing one concept. Not necessarily a single assertion, but that's generally a good rule to follow. But testing one concept about the state of the page. And so, so those are the general tenets I think about when I think about what makes a good test in a quantifiable way. And when I go to clients and consult and look at test code, these are the things that I look at, and these are the recommendations I make, which end up typically leading to more robust more maintainable, easier to read, easier to understand tests. There's of course the harder to automate things, harder to quantify things like good test names and that kind of thing, and that's a bit more subjective based on is it using good domain logic, and is it helpfully named, and that's kind of something you really have to pick up through tacit experience, unfortunately. But these are the things, these are the core tenets I think will get you 80% of the way there. And so I'll leave this up here for just a moment and encourage anyone that if you have any questions, to write them down and toss them into the questions input box on the GoToWebinar control panel. And also, I'll mention that these slides will be made available afterwards as well. So if you happen to be getting a cramped hand by writing all these down, or you're typing furiously on the keyboard, that's great. But if you happen to miss some of this in terms of transcribing, the slides will be made available afterwards. So I'm going to now switch gears and talk about page objects. So let's talk about page objects. And one resource that's really helpful within the Selenium community is the on the Selenium GitHub page. So if you go to GitHub and you search for Selenium HQ, you'll end up, or just Selenium, you'll find the project page, and then you'll end up finding the project. There's a wiki for Selenium, and the wiki has some really helpful information that's usually pretty well up to date. And one of those wiki pages is on page objects, and it's written from the perspective of one of the core maintainers. One or two of them have weighed in on it since then, but it's basically talking about what a page object should and should not be. It's also written from the perspective of Java, and so it's not really going to serve you if your language of choice isn't Java. But that's one really good resource. But a better one, which kind of is better in the sense that it's probably more generalized, is the quintessential blog post from Martin Fowler on his website about page objects. And so this dates back to 2013. Basically, great job of articulating what a page object should and should not be and why it's important. And then he, of course, links back to the wiki page on the Selenium project, even throws a quote in there from Simon Stewart about you might be doing it wrong if kind of situation. And so the general gist is that it's a pretty simple API. You're basically creating a programmable interface for the page, and not specifically like the inner workings of the HTML. So your test should be interacting with things like method names that have to do with the action you're trying to do, and then the page objects have to do with the actual interacting with the page. And this protects and shields your tests from brittleness. So if the application changes, you can just go into a page object and update it. You know, change the locators, update the behavior, that kind of thing. And then your tests just magically start working by virtue of that. So that makes them obviously more maintainable. And so page objects are, you know, kind of the tried and true like power law of do this pattern, and things will be a bit happier for you when you do test automation with Selenium. But what a lot of people don't talk about is like what really is a good page object, what isn't. Some people have opinions on it, some, and it just kind of varies depending on who you talk to. And so I have some core tenets I think are pretty straightforward for just a really a good way to get started and make sure you're on the right path with page objects. And so I like to start thinking about like, well, what makes a bad page object? And so I've seen page objects that are gigantic, absolutely absurdly huge, hundreds if not thousands of lines of code. And those, you know, were basically created and then added onto and eventually just not much rigor put around like, well, if it ends up exceeding like a few hundred lines, maybe we should consider breaking it down. And so people who inherit this just basically go, oh, I'll just, I guess, add to it too and make it bigger. And so if you see page objects that are gigantic, that's really not a good sign. They will likely be very onerous to maintain and potentially brittle because they might contain lots of really oddball stuff that could be happening, which can cause odd behavior in test code without you really realizing it, or if you change something somewhere, maybe it ends up breaking something inadvertently on the way other end of the page object. It could just be really, really challenging to maintain. And there could be overly complicated logic, unnecessarily overly complicated, although I guess you should really strive to not have complicated logic when you can avoid it, you should really, like good code, great code, should be blindingly simple, should be very straightforward in terms of what it's doing. And so if you have something overly complex, then it's maybe a good room for you to pause and reflect. And then the other thing you could end up with a bad page object is it may not return enough information, or it might return too much information back to the test. It'd be a leaky abstraction if that were the case, where there's not enough information for the test to perform its job, or you're returning and exposing too much information from the page object, which can lead to tight coupling to the page, ultimately, the actual application you're testing, which we're trying to avoid. We want to have that sweet spot of just the right amount of information being returned. So if the test breaks due to the page changing, we just have to update one thing really quickly in the page object and everything starts working again. And then, of course, a bad sign would be if assertions are happening in the page object instead of in your test, because your test is where the assertions should be happening, not in your page objects. So what makes a good page object? So there's things like it contains state. Like on the simplest concept of what a page object is, it could just be a plain class. It could be a simple class that contains state. It has locators. These are the elements, the HTML elements on the page that you want to interact with, and these are the incantations that you'll use to tell Selenium how to find it. And then you want to contain behavior. So you want to have methods that interact with the page. So in an example of logging into a website, you'd have a class that could just be called login page, and it could have variables at the top of the class that denote the different locators that we want to interact with on the page. So things like the username input field, the password input field, the submit button. And then we can have a method that's just going to actually log in. It's going to input text into the password and the username field and then click submit. So that would be an example of containing state and behavior. And then we want to, of course, return some information about the page back to the test. And so what that would look like would be one of two options, really, or three options, I guess, technically. So you'd either want to return something like text from the page or a Boolean result based on a question. Like if you wanted to see if an element was displayed on the page, you could ask that question of the page with Selenium and it would return a Boolean result. Or, and the more common approach, is to actually return a new page object. So in the example of login, if you actually log in, it should take you to a secure account page. And if that were the case, then you could have another page object for the secure account page. And then as the kind of closing act of the login page object, it would create a new instance of the secure account page and return that. And then the test would then be able to interact with the behavior on the secure account page. But the one thing you don't want to do is return a web element. This would be a case of where we'd be providing too much information from the page object back to the test. And so whenever you perform a find element with Selenium, it returns a web element, or web elements, depending on how you're actually doing the lookup. And so that's something that the page object is aware of and needs to be aware of, but that's not something your test ever needs to be aware of. That's just, anything that has to do with Selenium should be abstracted up to the page objects. And then one other thing that a good page object does is it verifies that the page is ready. It verifies the state of the page as part of its initialization. There's a couple different ways I've seen approach this. You could either put it in like a class constructor, or you can actually have a separate method, depending on how you build your page objects. And basically the gist here is that you want to make sure that the page that your test is about to interact with is loaded, and the things on it that you want to interact with are there. Otherwise the test will try to proceed, and the page won't be ready, and so the test will fail, and it might not be immediately obvious why. So you can just create kind of this checkpoint at the very beginning of when you create the page object. And so just like with the test rubric, I've created one for the page objects. And so each page object starts with 100, just like the tests, and you deduct points as necessary. And so things like lines of code. So I've picked a reasonably sized number for lines of code. So if you're if your page objects are greater than 200 lines of code, that should not be in your page object. But if you happen to have inherited or created page objects that are this massive potential cabal of code, then you want to deduct points. And there's no cap to this, which could be a real hurt for people who have like 1,000 or 2,000 line page objects. But you basically, for every 50 lines of code that are greater than 200, deduct 5 points from your score. And so that will add up in a hurry if you have very large files. Assertions. No, they shouldn't be in your page objects, but there is a caveat to that. There's an exception. When you're actually verifying the page readiness in the constructor or however you're doing it, you can use an assertion. That's like a good poor man's way to check to make sure that an element is correctly loaded, make sure that the page is ready. Ideally, you could do this differently. You could actually raise an exception instead of using an assertion. That's a much cleaner way that doesn't require you to actually import the actual test classes from your test framework for assertions. But that's just one example of that's something you could do, and that would actually be reasonably okay. But other than that, no, you shouldn't do assertions. And if you do, then for each one that's obviously not verifying page state, but actually maybe you're trying to assert that something else about the page, that should not exist in your page objects. And so -5 for each one. There's a cap of -20 for that. And then we're getting into the actual implications of the different weight strategies that you might be using in your tests for synchronization. Hard-coded sleeps just should really never be used. There's like a 1 in 1,000, maybe 1 in 500 situation where there's probably a good reason for hard-coded sleeps, because anytime that you have no way to dynamically determine when an action is to be completed, then that's a reasonable use case for hard-coded sleeps. But for majority of what you're trying to do with Selenium, then you don't need hard-coded sleeps. You really shouldn't. So if you see one, you should really flag it and put it, find a better way to actually wait in your code. And so for those, for each one, it's -5 with a cap of 20. And then the other two, implicit wait and explicit waits. So an implicit wait, ideally, you shouldn't use it. And I'll explain kind of the rationale as I get further down here. But the gist of it is an implicit wait is set to 0 by default. And so if you change it, then you hopefully know that you're changing it. But what ends up happening is you change it, and it's kind of a global maxim, right? Implicit wait means that when it's set, every time a find element action is called with that instance of Selenium that now has an implicit wait set, it ends up retrying an action until it can be completed, up to the amount of seconds that you've set. So if you set an implicit wait to 15, every time a find element action is going to be used, the find element, if it can't complete immediately, it will retry up to 15 seconds. And there's also some false positives and some race condition stuff in there with it, potentially, that makes it not a great option because it's not as thorough as an explicit wait. But the gist is, if you avoid implicit wait, which is actually the recommendation from the committers on the Selenium project, that in favor of explicit waits, even though it's a little bit more work, you'll end up with in a much sturdier position. But there are people who use implicit waits and get benefit out of them. So the easiest thing would be if you spot an implicit wait, then really you want to deduct 10 points. And this will help give you an indication of where to focus, and if you're starting to rethink and heed my advice and the recommendation from the Selenium committers that explicit waits are the way to go, then you'll be in a better position, because this will help you identify where those issues are, or where the implicit wait calls are, because they will actually create potentially transient test failures for a number of different reasons. But explicit waits are better, and so of course you deduct no points. And so for those of you that are not aware of the difference between an implicit and explicit wait, I'll just briefly mention that. So an implicit wait and explicit waits fundamentally are very similar in that you set a timeout. You call it and you set a timeout. And Selenium will retry a certain action, and in the case of an implicit wait, it's every find element. And in the case of explicit waits, it's only when you call it. It will retry for those actions until it can either do it successfully or it hits the timeout and then return an exception. Implicit wait is the kind of thing where you should set it once and then forget it, basically. Set it and forget it. Explicit waits are whenever you want to use it, and you can change the value every time you use it. What I see is a lot of anti-patterns around the use of implicit wait, which is the reason I think it's a dangerous thing. I think that people don't realize that an explicit, they're basically, people are taking an implicit wait and then using it and turning it like a dial. And so they set it during test setup, and then in a page object they change it, and then they change it again later, and this has potential ramifications for a test when it's in flight. It can cause, it can cause an element you think is waiting 15 seconds to actually only be waiting 5 seconds because a different command somewhere else in the page object could potentially have set it to a different value. Whereas with an explicit wait, you set it, it's explicit. This is how long it's going to wait. And actually, you could theoretically combine implicit and explicit waits together and override the implicit wait with an explicit wait, but don't do that. Don't mix them. And if you see that you're mixing them in your test code, really work diligently to try to fix that, because there is actually a not so well documented bug where if you mix the two together, you'll have some transient test failures, depending on which browser OS combination and how you're running your tests. But the general gist is just use explicit waits. Like, that's the recommendation from the project. That's the best way to go about it. And implicit wait is a good way to get started, but it's not a great way to kind of grow your testing practice. So moving on, wow, that was a long tangent. Moving on, so verifying page ready state is something that you really want to do in your page objects, and so something to be said here, you really want to make sure that when you're verifying the page ready state, you're verifying something relevant on the page that denotes that the page is ready to be interacted with. I see a lot of places where people have used URL lookups to say, like, well, it's on this URL, so I'm good to go, or they look at the title of the page, like the actual title attribute of the page. And these are not good indications that the page is loaded. It's an indication that you maybe ended up in the right place, but it's not a good indication that the page has actually loaded to a point that it's ready to be used. And so this could actually create false positives and cause your test to derail anyway, and you have kind of a false sense of security around the way you're verifying the page ready state. And so -8 points if you're not verifying an element on the page. So really, you could perform a find element to see if something is displayed on the page, or something is clickable, or something, there's a bunch of different expected conditions that you could use to wait for. So basically, it's a good candidate for using an explicit wait and waiting for a specific element. And so so that's basically it. So use an element, look for it, make sure it's something that can be interacted with, and then if it is, then the test can proceed. If not, then it should fail, but not something like checking the URL or checking the page title. And then locators, obviously, since Selenium commands should be in your page objects, locators are the lifeblood of kind of everything we're doing. Like, without locators, then Selenium won't know how to interact with the page. So those should end up in your page objects. And there's no deductions here. The only thing to mention with locators is that they should theoretically, ideally, they should be stored in a central place within the class. They shouldn't be strewn about in line. Like, you should put them in a variable at the top of the class. So if it's Java and you're using just a simple Java class, then you put it in a field variable at the top of the class. This enables you to use that variable in multiple places in the class, and then only gives you one place to update it if, for some reason, the locator needs to change. And so that's the rubric for grading your page objects, finding a repeatable way to make sure your page objects are robust and following a good construct. And so I'll leave this up here for just a brief moment and encourage anyone that has questions to put them into the question box. Okay, so moving on, let's go to the last topic, which is kind of the lion's share here, because I think it requires a good amount of time to talk about, and that's locators. And but before I do want to mention briefly the tangent I went on about explicit versus implicit waits. This is a link to a Stack Overflow post where somebody was asking a question about transient test failures in their Selenium test code, and Jim Evans, a longtime committer of the project, for those of you that don't know, Jim is kind of the guy who doesn't require an introduction. He created IE driver. C# bindings. Like, he's kind of a legend as far as I'm concerned within the Selenium ecosystem. But he answered very thoroughly a question as to why this person was experiencing transient test failures, and it had to do with the fact that they were mixing implicit and explicit weights in their test code, and that it led to a undocumented bug that was really due to an architectural limitation. And depending on the browser that you're testing with and whether or not, it just goes on and on. There's just a lot of detail to it. And so I think that this just further bolsters the position of the Selenium committers about using explicit weights. And so I encourage anyone that kind of is more curious about the position about implicit versus explicit weights to check out that post. So without further ado, let's talk about locators. So within Selenium, there are 7 different locator strategies, and they're all listed here alphabetically. And the way I typically think about locators is that they should really be unique, descriptive, and unlikely to change. And so for simplicity, I just think, let's just roll a few of these out based on this criteria and think about starting with IDs and classes. There's 2 reasons for that. IDs and classes are the most performant, the quickest way that Selenium can interact with elements on the page. It's the fastest lookup that's available. And also, if an application that you're testing was built to follow the HTML spec, which more often than not is unfortunately not the case, IDs and classes theoretically should have helpful, unique, descriptive, and unlikely to change names on them that you could use, and so that your tests would be very straightforward to write. And when that is the case, then it's great, and things work really well, and they are very fast. But that's often not the case, and when that happens, you need to reach for CSS selectors or XPath. Now, you do want to handle CSS and XPath with care, because you could write very brittle, very slow, dangerous locators that end up being things that later on can break your tests inadvertently. And so this is an unfortunate reality when you're trying to write automated tests for an application that wasn't built with testing in mind, and you're kind of figuring out the best way to kind of kludge something together and you get it working. But then if you have to go back and maintain it because the page changes slightly and it was a very brittle locator to begin with, it's just kind of a nightmare. And so that's just something to consider. CSS or XPath, both are good when you don't have the happy path of IDs and classes. And so there is actually this kind of contention within the Selenium ecosystem, which has to do with which is better, CSS or XPath. And for a long time, and even still today, there's this kind of assumed knowledge that XPath is potentially inferior, or it depends on which side of the argument you're on. Some people think XPath is far superior. Some people think CSS. And so it's really interesting. There's 2 reasons that this argument happens. One is that people don't actually understand that both with CSS selectors and XPath you can accomplish almost entirely the same things. There are some areas where XPath is more powerful, but they're typically for cases that you don't need. And so I think that people just have their preference and have their experiences and know what they know, and so that's fine. And so I generally encourage people to use which one they're more familiar with. The more recent or semi-recent argument that people kept harkening back to was that XPath was slower. Or basically there's a performance benchmark that was cited that ended up being, it's at least 4 years old at this point, where there was actual data at one point that reflected that XPath was considerably slower depending on which browser you're using with Selenium. But Selenium's since gone through so many major upgrades in full version number, at least being one of them, from Selenium RC to Selenium WebDriver. And then there's, of course, the fact that browsers constantly evolve as well. And so the argument of which is faster is actually somewhat irrelevant. And so to kind of help further the point, I've gone back a couple years ago and I reran benchmarks between locator lookups with CSS and XPath between the different browsers at the time. And then more recently, within the last few months, I reran those benchmarks again. And so I'll show you, I'm going to share with you kind of the more recent benchmarks that I've seen. And so there's kind of a longer write-up that I have about this. It's on my website that I'll add a link to this slide before I post them. But basically, I went through 3 iterations, and the last one I ended up with had a lot of input from committers on the Selenium project around what kind of an application would reflect a really good test for Selenium, and then what kind of process. So all the benchmarks I've done is using a very large and deep nested DOM example, and I'm using an actual benchmarking library in Ruby, and all of the locator. This application is running on my machine, and all the locator lookups are happening, numerous times to kind of remove any sort of inconsistencies in terms of load time. So there's like 3 different blog posts, each about 1,500 words, that kind of go through the process I went through. So again, I'll link to that so you can have it if you're curious about what went into this. But this is a very large and deep nested DOM. It goes well below what you can see here. It goes actually 50 divs wide. There's a huge table at the bottom, and there's different locators that I'm using. And so the first 2 are horrible locators. They're gigantic. They walk through the whole DOM, and then these other ones are more reasonable. But these first 2, as I mentioned, are horrible. They just keep going for days. These are locators that you should never, ever, ever use. And so, for argument's sake, though, I'm using them so I can actually prove a point about the different performance benchmarks between browsers. And so let's talk about Chrome. So between Windows and OS X, so it's a little bit of a performance difference, generally speaking, in terms of how long it takes things to load. It could be partly because of the virtual machine that I'm running, but largely I think it's showcasing the difference between XPath and CSS selectors. So on the left are so basically it goes in order of the locators as it was shown in that little notepad document. And so the first 2 are the worst, and then they get better the further to the right you go, basically. And so you can see that within Chrome, there is, at least on Windows, there's a couple of locator lookups that are a little bit worse, but in the relation to what basically the timescale showing seconds. So at most on Windows, it's taking up to 2.5 seconds for a locator to be found, and so compared to just over a second. So only one of those locators actually is a 2-to-1. Everything else is reasonably consistent. And again, these are some pretty rough locators, and some of them are less rough. And then on OS X, there's more of a pronounced difference in terms of the execution times, but again, the timescale is actually much smaller here, where it's actually sub-second. So 700 milliseconds for the slowest of the locators versus almost 400 milliseconds for the slowest. So it's close enough. It's basically within your test code. You're not going to notice too much of a difference. And again, one detail I did not mention, this is actually not for a single locator lookup. This is actually the median of 100 different lookups. So actually, the individual locator lookup, if you were to perform this in a test, would actually be probably less than a millisecond. So I basically ran this benchmark data numerous times so that the numbers would actually be just easier to kind of represent here. So, but generally speaking, things are a bit more tuned. Basically, the moral of the story here is in Chrome, CSS selectors are what's tuned for. So they're more performant than XPath, but not to the point of the data that used to be reflected, which was XPath used to be something on the order of it would take minutes to accomplish a lookup, whereas with CSS selectors it would be very trivial. And so really it is a trivial comparison, but it's slightly faster in Chrome for CSS selectors. Whereas for Firefox, it's even more obvious that it's being tuned for CSS selectors. XPath obviously it's almost 2-to-1 across the board for Windows and then on OS X for Firefox, it's even more obvious. It's like a 4-to-1 in terms of the latency. So CSS selectors are clearly faster when it comes to Firefox. But again, it's not to a point where it's so slow that it's something that you should be concerned about. And then the outliers here, Internet Explorer 11. For one of the worst locator lookups is, of course, the most poorly performant ones. It's almost 20 seconds to load. But other than that, CSS is actually a little bit slower in Internet Explorer. XPath's a little bit faster. Whereas for Safari, it's kind of a smorgasbord here. CSS is a bit faster. So generally speaking, with the exception of Internet Explorer, CSS selectors are actually faster, but not to a point where you should consider XPath to be completely trash and throw it away. But then again, it goes back to one of the 2 points I mentioned earlier, which is CSS. Go with what you know and what your team is kind of fluent in with regards to the locators. I generally recommend and encourage people to use CSS selectors because it gives you a common language to have a conversation with the front-end developers. So the people that are building the application that you're potentially trying to do tests for, ideally they're involved in the test writing process, but if they're not, and you have to have a conversation with them to find a locator, they're probably going to give you a CSS selector. They're not going to give you an XPath. And if you are both having that same conversation in the same language, then that's going to be a much more efficient conversation. But hopefully this data has reflected that it's up for grabs, but the browsers are typically tuning for CSS selectors over XPath. So that leads to the locator rubric. The best way to think about this is that instead of kind of starting at 100 and then deducting points, you should look at each locator that it gets a grade. Every locator gets a grade. And so I'll start from kind of the worst offenders up to what the gold standard is for locators. Over time, I think that this list will become more comprehensive, but I think these are the broad strokes that really capture what would make a good locator and help identify which locators are not that great, which mainly I think from everything I've been talking about today follows one general strategy, one specific thing, and that's how do you write your tests so that they will be reliable over time. So if the application slightly changes in terms of how things are laid out, the test won't break because the locators are brittle, or it's easy to maintain. So really it's just something like you create a test and page objects and you want them to last. You want them to work and be reliable and give you helpful information. So these locators fit into that strategy. And so this is basically a hopeful way for you to get kind of an information radiator about which locators are good and which locators are bad. And if you're using any of these within your test code, it'll help point you to which ones need attention. And so dynamic locators, just D-. What I mean by that are things like user account specific information or things that are tied to page render. So if you're thinking about like if it's a lot of data on the page that's pulled from an account. So maybe it's just like if you're purchasing, if you're doing some kind of walkthrough a financial account and you want to update information about purchase history or something, it would list potentially IDs on the page. A common pattern is IDs on the page that have a number in them. And so this is typically either tied to something like a user's ID in the system, or it's actually just a collection of numbers that just change every time a page loads. So either it's tied specifically to the user that you're testing with, and so if you take this exact same workflow and use a different user account, it would have a different ID because that ID would be changed to reflect the ID of the new user, or you have something like a bunch of elements on the page that are just random numbers that are getting added for the IDs. And so every time you refresh the page, it would change. So these would be obviously horrible locators because they would create very brittle tests that would not be reliable over time. And so that just gets a D-. Anytime you basically, the easy way would be if there is an ID and it contains numbers, then it likely is a dynamic locator. It's very seldom where I see IDs that contain numbers that are not dynamic. So things that are tied to page layout, like really tightly tied, like the horrible locators I showed you for doing the benchmark data, those just get a D. Those are absolutely guaranteed to, at some point in the reasonable future cause your test to fail for no good reason. And so a simple way to think about this would be XPath or CSS selectors. If they contain 3 or more slashes for XPath or greater than symbols for CSS selectors, then they are likely very tightly coupled to the page. And so those are very brittle. And so you should be able to basically take a glance. If you see more than 3 slashes, oh, that's a D. More than 3 greater than symbols, oh, that's a D. Text is the next one, text on the page, because within Selenium you can actually do a lookup on the text of a link or a partial link lookup. And anytime that you're dealing with looking up and verifying even copy on the page is another case, which kind of speaks more to your assertions, but purely on locators. Anytime you're doing a text-based locator like link text, it's a C. Excuse me. And so that's basically it. It's very straightforward to see it. It's very, I mean, there's times where you might need it though, but even still, there ideally should be an ID or some other way to interact with an element rather than just using the link text, because copy could so easily be changed by somebody that's not a developer, potentially. You know, if it's something like there's a CMS and it's like the link text is controlled through the WYSIWYG editor, like the page could change, your test will break, and it's just out of band of any development work efforts, and it's just noise. It's just unnecessary changes that have to happen in your test code. And so when a test fails, it's just a false positive. So strive to avoid those, grade those with a C. And then we get kind of into the more reasonable locators. So ones that require reasonable traversal, not tightly tied to page layout. So things that are reasonable with their traversal of CSS and XPath get a B. And so I don't have a specific concrete example, but basically the way I think about it is if you have something on the page you want to interact with, and there is a parent and a child, it's within, if it's just a specific, like a widget on a page basically, if you can actually scope to the top of that widget and then scope from there into a child element within it. So if the child element doesn't have a locator that's unique that you could use, then this would be a reasonable way to do that. You can scope to actually, I do have a reasonably okay example. So I have there's a login form I was testing recently where there's a submit button, but there's no helpful ID or class on it, but it's part of the login form. And so and there's an ID on the login form. So I could actually traverse from the ID of the login form into the button. And so that way I know that I'm only going to interact with the button that's part of the login form. And so that's an example of reasonable traversal. And then using semantic name is pretty reliable typically. I'd say it's potentially B+ worthy. And so input labels on forms is a classic example of this, where there's like a name attribute and name equals. Username for login field example. You know, that kind of information generally doesn't change for forms. That kind of semantic information denotes the actual domain information and the behavior that's supposed to happen, who's supposed to interact with it. And so those are generally pretty good, reliable options to use. And then the gold standard would be a semantic ID. And so A for that, and those are, of course, ones that are unique, descriptive, and unlikely to change. So IDs that don't contain numbers, basically, that denote something helpful and informative about the thing that you're trying to interact with. So for in going back to a login form example, if a username input field has an ID of username, then you could just do ID equals username, and you're off to the races. And so, and if you know, or if there was, yeah. So basically, that's it. Like an ID that just has some sort of helpful name about what it is you're trying to accomplish. And so there are some front-end developers that feel like this kind of can clutter up the markup of a page. But if you don't have them, then you really can't do any sort of test automation. And so that's where a conversation really needs to happen. Once you can kind of earmark and identify all the locators that you're using, apply this rubric, see where your tests stack up in terms of locators that you're using, and then have a conversation with the front-end developers about these are the kinds of things that we need to make this page more testable. And then once you do that, you can redo this grading rubric and then see how you've improved. So again, I'll just leave this up here for a brief minute. before I move on? Okay, so there's one thing I didn't mention, which was ideally, as I mentioned, they should be unique. Locators should be unique, and so all of them really should be. And if not, then you should deduct 2 full letter grades. Because so in the case when I described reasonable traversal, if you didn't do reasonable traversal to interact with a button that's part of a form, and you just said, I want to just grab this button, it's the only one on the page. If a second button, if actually there were 2 buttons on the page, then Selenium would find the first one and interact with it. But it wouldn't be unique. There would be 2, and if the order on the page changed where this second button instead got moved up in the hierarchy to above where the button you're interacting with was, then your test would fail. Non-unique locators have a great potential for causing brittleness in your tests, and they can be inadvertent because it's just like the second line item here tied to page layout. Something that's tightly tied to page layout, when the page order changes, causes your test to break. Same thing happens for non-unique locators, which can happen regardless of which locator that you're using in terms of this grading scheme. So you could have a locator you think is pretty good, but it could also be non-unique, and so then you'd really want to strive to maybe make it a little bit more unique, so that it it could be more reliable over time. And so this is kind of the final gotcha as far as locators are concerned. So what is your testing GPA? So the way I think about it is once you've gone through with your grading rubrics for each your tests, your page objects, and your locators, then you can kind of tally them up for each page object, each test, and then kind of come up with a cumulative grade. Whereas also when you drill into it, you can see what each test and each page object and each locator has scored. But the way I do it is I weight it based on tests, page objects, and locators. So tests in a cumulative GPA would be 20% of the grade point average. And then page objects would be 30%, and locators would be 50% because they're without locators you have nothing, and they move the needle the most in terms of whether or not your tests are reliable, just in terms of how they're interacting with the page. So that's how once you tally things up and go through the rubric on your own, this will help you in terms of how to actually put that all together into a final grade. And so I'll just leave before we start taking questions. There's a couple of things I wanted to mention, and one of them is there is a Selenium Conf coming up. We just had one in June in Bangalore, India, and we're doing a second one this year, and it's coming up really soon. It's coming up in November, and we just published all of the sessions. We've accepted all speakers, and we've started putting together the program, and we're really excited and really proud of the program that we put together for this year, for this fall. And so tickets are selling out quick, and so if you're interested in attending, then be sure to check out seleniumconf.co.uk. There's still a couple of workshop sessions that are available. Some of them sold out, but there's I believe the Getting Started and the Committers workshops are still open. And the program can be viewed on the website in terms of who's been accepted and also what talks they're giving. And so right now the general tickets are there's still some general tickets available, but once they sell out, then the price goes up because we're ending up into the last call them the last chance tickets, so the final block of tickets. So if you want to, if you've been thinking about attending or interested in checking us out to attend, be sure to move quick to buy your ticket before the price goes up. And then the other thing I want to mention is that Applitools, the gracious organizers of this webinar, they have an ongoing kind of recurring webinar that they do. It's a 45-minute session, and basically the gist is that it shows you kind of the gist of automated visual testing and how to get it incorporated into your existing test practice. And so you could take your existing Selenium tests and incorporate automated visual testing, which is something I do in my tests, and I think it's honestly, it's interesting to see the industry having evolved over the last couple of years. Automated visual testing is something that I think everybody should be paying attention to, and I think most people are starting to pay attention to it quite seriously. And Applitools Eyes has, I think, the best tool out there for automated visual testing. There's some great open source tools out there too, but Applitools Eyes, hands down, is an impressive offering. And so for a 45-minute session, you can learn how to basically become a master of automated visual testing. And there's so many powerful benefits that it just takes your existing Selenium tests and helps you automate something that most people just don't even know that they can automate, which is basically checking the visual rendering of a page using computer vision and machine learning and just all this really cool stuff. And so basically, I always tell people that the future is here, and for a few lines of code, you too can be in the future. And so check out this webinar. There's a bunch of different time slots. Go to this link to find it. And so you can sign up, pick a slot, and then it's worth checking out. So, and so that's it. So we now will start taking some questions. Adi?
Yeah, thank you. We are actually painfully out of time, but if people, whoever can stay with us for a bit longer will enjoy some answers to some of the questions. We have a lot of them. And I'll start with the first one. I'm going to merge two questions here. We got a lot of questions about conditionals. So when and where should these conditionals be put? And the second one was, if conditionals are not a good practice, how would you use a model test, for example, log in for various environments where only the URL is different?
Okay. Okay. So conditionals, ideally, all of the logic that you end up with in your tests should be in your page objects. So if you end up with conditionals in your tests, it's worth seeing if they can be moved from your test into your page objects. And so that's really the kind of the reasonable place for it. And logic that has to do with different interactions on the page. But typically, I wager that if you put enough thought into it, you could actually find a way to write code that doesn't require conditionals. But that might be a separate topic entirely. But for argument's sake, the simplest thing would be move it out of your test and into your page objects. But if you're dealing with things like the URL is constantly changing, or basically if you want to run the same test on different environments and the URL is changing, then I would, there's a couple different ways to handle that. And one way would be to make it so you can pass in you can make it so there's a base URL for your test code so that it all leverages this base URL, which would be just the environment that you're using. And then your page objects would just use a URL path. And so at runtime, you can specify a different base URL and have the test run on a different environment. If you wanted to just have a test actually run through, or a set of tests run through and do the same thing but on different environments, just have one shot do it, then you can do what's called a parameterized test and have a collection of URLs and then pass those into your page object potentially. And so there's a couple different ways to scratch that itch, but that would be how I would structure it. I would start with, is there a way to basically put the burden somewhere else, either through the actual test harness that I'm writing or parameterizing the test.
Okay, next question. Is it okay to have UI tests testing the same thing as API tests?
UI tests testing the same thing as API tests. I think that if you can test, if the business logic exists not in the UI, like if the business logic is in the API, then I would say test through the API, and Selenium isn't the best tool for the job. But I would wager that you'd want a couple of tests through the front end so that you could at least make sure the broad strokes of an actual user stepping through the system exist. But to get as granular as testing a specific thing that you could already test through the API, I would say that's not the best strategy. API tests are orders of magnitude faster than Selenium, and API HTTP libraries are the right tool for the job, Selenium is really the best tool for the job when there's a user-specific behavior you want to test through a browser. So if you can test this elsewhere, I would encourage people to do that.
Okay, the next question is actually from one of our customers. When doing visual tests with Applitools eyes, should Applitools eyes be integrated in the page object level or in the test level?
Oh, that's an interesting question. I think you could do either. I mean, it really depends on how you structure things. Typically, I think when you're just getting started, you could very easily just do it in the test level, and then as you start to have things be more robust, you could move things into the page objects. Because there's specific checkpoints where you would want to perform what's called a check window. So you take a snapshot of the page, which you would then compare to a baseline image, a snapshot that was previously taken for the same page at a different time, and then it would compare those two together. There's times where you definitely want to have tight control about when those check windows are happening, and if if the flow is happening for the user in the page object, then you really want to start moving things up into the page objects.
Okay, another question is, what is the ideal score range?
Well, it's just like when you're in school, right? It's like, what's the right grade for you? I think that I mean, there's no perfect grade other than getting an A across everything. Those are the gold standards. But the reality is that your hands are tied because the application you're testing isn't built for testability. And so really this is meant as a helpful information radiator for you to figure out where you need to improve, both in terms of the tests and test code that you have, as well as what led to the decisions as to why things are like they are. And if it points you to, well, the application is just hard to write tests for, then that leads you to a conversation with the developers to make it more testable, which then improves the test code. So if, ideally it would be, the higher the grade, the better. Anything below a B is really kind of potentially just a brittle, hard to maintain, or it's on a slippery slope to becoming that way. So I would say aim your sights high and just strive to hit as high a score as you can. But it's probably not possible to get a perfect score unless you're building something brand new from scratch and have all the stuff in mind.
Okay, there are a lot of questions, so I'm just browsing through them. Next question, how do we score page objects?
Just like I showed with the rubric, you take a page object and then you start with 100 and then you deduct based on the things that I listed in fractions, essentially. And then you end up with a score for that page object, and then you proceed and you could do it again. And so you just take that rubric and apply it to each page object that you have.
Okay, and I think the last one that we're going to have, because we are, as I said, painfully out of time, can we have multiple assertions in a single test?
This is a question that comes up a lot, and I think that the classic answer is always it depends, but I think that the reason behind why that question is typically asked is we just went through all this expensive time to get the browser set up, to get to the correct place with the correct user, and there's multiple things we want to check. And so I think if you're testing something, if you're testing multiple things, potentially, it's tough to say though, because what could happen is that you could end up with, you could test, say there's 3 assertions, and the first one passes, the second one fails, the third one never gets run. So that's an issue where you end up, you don't know if that last thing was checked or not, and what if that's the most crucial thing? And so there's 2 different ways to think about it. You could potentially find a way to write a single assertion that checks 3 things. And so, for example, if you have three things on the, if you're testing for broken images, which is the example I tend to show people, if you could find which images on the page are broken and store the URLs to those images or the names of those images in a collection, you could compare that collection to an empty collection. And then when you run a single assertion to compare the two, it would say, oh, these three images were broken. Like, because I expected nothing, I got these three. Whereas you could just say, I want to test these three images. So that's a much cleaner way to do it. It's a little more sophisticated, and it might not work for every case. The other option would be to write separate tests for each assertion that you want to do and then run them in parallel, which arguably would be the same amount of performance, but has more overhead in terms of setup and all of that. So the short answer is yes, and see where it gets you, and just if each thing you're asserting is of reasonable importance, like not one thing is more important than the other two, then I would say that's probably okay. But if there's something that's absolutely crucial, then it probably should be in its own test.
Okay, Dave, we are over time already. I think almost 15 minutes over time. So I think we're going to cut off at this point. I just wanted to mention again that the recording will be sent tomorrow to everyone, and we're going to leave the current slide up for another minute for everyone that still hasn't copied the information and or wants the links. So Dave, thank you so much for this in-depth session, and thank you everyone for joining us today, and I hope to see you at our next event.
Yeah, thanks everybody.